After studying this module, you shall be able to understand the concept of ammunition. Second, learn about the different components of various ammunitions. Third, learn about the different types of propellant and primers. According to section 2(1)(b) of Indian Act of 1959, ammunition means any artillery that can be used in combat or warfare. It includes rocket, bomb, grenades and other live missiles. Article designed for torpedo services and submarine mining. Other articles containing or designed or adapted to contain explosive, fulminating or fissionable material or noxious liquids, gas, etc. Charges of firearm, accessories of such charges, fuses and friction tubes, parts of the machinery for the manufacturing ammunition. Most of the crimes committed involve use of small arms, which consist of cartridge, propellant, primer, projectiles.
Small arms. Small arms ammunition is of two types, metallic ammunition and shotgun ammunition.
Now we shall look at the different components of a metallic and a shotgun cartridge. Components of metallic cartridges are: A. Metallic cartridge case, shell or empty. B. Percussion cap. C. Propellant or gunpowder. D. Bullet. And those of a shotgun cartridges are: A. Paper cartridge case, shell or empty. B. Percussion cap. C. Propellant or gunpowder. D. Spherical ball or lead pellets. E. Overshot wad, undershot wad, air cushion wad, and overpowder wad.
The projectile charges of cartridges are further classified, which is given in the following table. Number LG has number of pellets 6, diameter of pellet 9.14 mm, weight of one pellet is 4.73 in grams. Similarly, SG has number of pellets 8, diameter of pellets 8.43 mm, and weight of one pellet 3.54. SSG has number of pellets 15, diameter 6.83 and weight is 1.89. AAA has number of pellets 35 and diameter of pellet 5.16 mm and weight of one pellet is 0.81. Similarly, A has number of pellets 50, diameter of pellets 4.57 in mm and weight of one pellet 0.57 gram. BB has number of pellets 70, diameter of pellet 4.09 mm and weight of one pellet 0.41 gram. Similarly, we have others which has corresponding number of pellets as well as diameter of pellet and weight of each pellets. Now we will learn about the blank ammunition. A blank is a charged cartridge that does not contain a projectile. To place the propellant, the opening where the projectile would normally be located is crimped shut and or it is sealed with some material that disperses rapidly upon leaving the barrel. Actor John Eric Hexum died when he shot himself in the head with a blank, and actor Badon Lee was famously killed during filming of the crew when a blank fired behind a bullet that was stuck in the bore drove that bullet through his abdomen and into his spine. The gun had not been properly deactivated, and a primed case with a bullet instead of a dummy had been used previously. Someone pulled the trigger, and the primer drove the bullet silently into the bore. Blanks are used in training but do not always cause a gun to behave the same as live ammunition does. Recoil is always far weaker, and some automatic guns only cycle correctly when the gun is fitted with a blank firing adapter to confine gas pressure within the barrel to operate the gas system. Blanks can also be used to launch a rifle grenade, although later systems used a bullet trap design that captures a bullet from a conventional round, speeding deployment. This also neglects the risk of mistakenly firing a live bullet into the rifle grenade, causing it to instantly explode instead of propelling it forward. Blanks are also used as delicate launchers for propelling or grappling hook, rope line, or flare, or for a training lure for training gun dogs. The power loads used in variety of nail guns are essentially rimfire blanks. Next we will learn about the propellants. What are propellants? The expression propellant means an agent which fires the projectiles out from a firearm. In order to propel a bullet or shotgun charges through the barrel and air, a certain amount of force is necessary. The powder charges gets ignited through primer and converts it into gas very quickly, thereby resulting in development of high pressure in the cartridge and forcing the bullet to get out of the barrel. There are three types of propellants that are used: gunpowder, which is also known as black powder, smokeless powder, and the semi smokeless powder. Now we will learn about these propellant in detail. First one is gunpowder. Gunpowder is the oldest recorded propellant and had been invented by Chinese around the 20th century. It was used for giving signals and fireworks. The gunpowder consists of potassium nitrate, sulfur, and charcoal, roughly in the proportion of 75-15-10. The powder is not suitable for high velocity ammunition, as large amounts of powders are required for getting high velocities for the projectiles. The powder leaves a considerable amount of solid residue, which tends to foul the barrel. It remains fairly stable if kept dry over prolonged period. It is gassed and polished to increase its storing or keeping qualities. The gunpowder causes much smoke and falling of the target. It is mostly used in muzzle loading and blank cartridges. The powder is available with different grain size from mesh limit 6 to 10 to 46 to 60, and they are designated as FG and Tetra FG respectively. Next, we will learn in detail about the smokeless powder. The modern high velocity era started with the use of smokeless powders. The basic constituents of smokeless powder are nitroglycerin and nitrocellulose, also known to be gun cotton. Nitrocellulose is neither used alone or in combination with nitroglycerin to form propellants. The latter are known as double base powders, while the former is known as single base powder. Some of the double base powders that are commonly used contains nitroglycerine. Nitrocellulose and mineral jelly are cordite, modified cordite, and ballicite. The composition of common double-based powder is detailed. First one is cordite that has 58% of nitroglycerine, 37% of nitrocellulose, and 5% of mineral jelly. Next is modified cordite that contains 30% of nitroglycerine, 65% of nitrocellulose, and 5% of mineral jelly. Next one is ballicite, has equal quantities of nitroglycerine and nitrocellulose without any mineral jelly. Smokeless powders degrade with time. However, the lifespan of each powder has been increased by improving technology and by addition of stabilizers. It is important to note that smokeless powders do not explode inside a cartridge. Instead, they combust. Since the combustion is occurring in a closed space, it can have the force of an explosion. Next category we have semi-smokeless powder. Semi-smokeless powder is a mixture of black powder and nitrocellulose. The approximate composition of powder is given as follows: nitrate wood cellulose, which is 20%, potassium nitrate, which is 60%, carbon, it is 12%, and sulfur, it is only 8%. This powder produces less smoke than gunpowder, but mixing process is quite dangerous. This aspect has prevented its extensive production and use. Next one is triple based powder. The triple based powder contains the nitroglycerine, nitrocellulose, and black powders. The percentage of various constituents vary but do not offer any special advantage. Hence, they are used. Next is RDX based propellant, a new propellant in which the active ingredient is from the family of cyclotrimethylene triamide, that is RDX, has came up. It is being utilized in the manufacture of cartridges by controlling not only the shattering nature of the high explosives but also its heat production. The advantages are obvious. The rate of fire can be increased without determinal effect on the weapon firing, the ammunition. However, its composition and other details are not available presently. An ideal powder should have the following features. First one, it should be stable on storage. Secondly, it should not be corrosive. Thirdly, it should produce minimum amount of smoke. Fourthly, it should produce minimum amount of heat for a given velocity. And last one, it should be homogeneous. Same amount of powder should give same velocity. It is mainly to improve these qualities that most of the research on propellants is being done. In addition, reduction of production cost and increase in safety margins are other important considerations. Consequently, new propellants are always lined up in the market. Next, we will learn about the primers. The primer composition has the following basic ingredients. First one is an inclinator. It is a sensitive high explosive. Next we have fuel. Next is an oxidizer. And the last one is stabilizer. The sensitive high explosive, which functions as an initiator, is a pressure sensitive material which gives out a flame to ignite combustible material, which work as fuel. An oxygen supplier would supply necessary oxygen so that combustion of fuel is proper. A friction causing material is also mixed with to carry out the functioning of the entire exercise in a satisfactory manner. In 1807, a Scottish clearman, James Forson, the discoverer of the shock-sensitive explosive called mercury fulminate. This type of explosive will detonate if it is struck or by the shock. A spark will also be generated. By 1850, cartridges which were being manufactured contained mercury fulminate inside the rim of the cartridge. The development of the cap combination has been a fascinating and dangerous adventure. It was one of the most important steps in the development of firearm. It gave a final blow to the matchlock, flintlock, and wheel lock mechanism. It also gave an all-weather cartridge. The composition of mercury fulminate primer by weight is produced. Mercury fulminate 8 parts, potassium chlorate 14 parts, antimony sulfide 18 parts, sulfur or gas 1 part, and similarly gunpowder 1 part. Mercury fulminate primer suffer from a number of drawbacks. First one is mercury fulminates gives mercury on ignition. It makes the brass cases brittle and consequently unfit for frequent use. Secondly, barrels get deteriorated quickly because of the deep position of mercury on their surface. Next is potassium chloride. When ignited, produces potassium chloride, which absorbs moistures, resulting on early rusting of barrels. Next is powder glass particles, if used, will abrade the barrel, resulting in the increase of bore diameter. In the view of the above defects, the new primer compositions have came up by replacing mercury fulminate. In our country, the new primer composition being used is as lead stephanate 32 to 40%, antimony sulfide 13 to 17%, barium nitrate 27 to 37%, PETN 4 to 6%, tetracene 3 to 5%, and aluminum 6 to 8%. In military ammunition, mercury fulminate as the main ingredient and has been replaced by stephanate in most of the countries. The other two important points with regard to primer to be kept in the minds are: first one is the primer composition mentioned above are used in all systems of ignition, namely the rimfire, penfire, and centerfire cartridges. Secondly, when the gunshot residue is analyzed from the hands of a shooter, the examiner should look for the particles of antimony, lead, and barium from the primer. Next, we will learn about the WADs. In shotgun ammunition, there are number of WADs. First one, over powder wad. Second is cushion wad. Third, undershot wad. And the fourth is overshot wad. They keep the charges in the cartridges in their proper places. In addition, the cushion wad seal the barrel on firing and thus prevent escape of gases and consequent loss of velocity. They also clean and lubricate the barrels. Overpowder, undershot, and overshot wets are made up of special quality cardboards varying in thickness from 2 to 3.5 mm. They are waterproof. They are slightly larger than the bore of firearm for which they are intended. We have given table which shows the wet diameter of various shotgun ammunition, bore diameter in inches, and wet diameter in inches. Next we have cushion wets. These are made from flat cork, felatin, cardboard, and from plastics with air holes. They seal the barrel properly and prevent escape of gases. The cushion wets are about 12.5 mm thick and are often greased. The grease lubricates the barrel. The modern shotgun wedding has undergone several changes in the last few decades. The changes are: first one is the base wet is plastic mold and fixed in the base of the brass head under pressure. Second is the over powder wet has changed to an inverted cup wet open side towards and over the powder so that when gases are formed, the open round edge of the cup is pressed with the pressure against the barrel and thus it seals the bore. It prevents the escape of gases from sides. Next is the cushion wet's functions is carried out by cup wet and piston, which is attached to the rectangular projectile sleeve containing and protecting the projectiles from coming in contact with the barrel and consequent damage. The sleeve has cuts along the edges in the frontal part. The four sides of the sleeve open up and fan out along the cuts. When the sleeve comes out of the muzzle, the sleeve gets separated from projectile charges. They are being lighter falls down. It does not interfere with the shots in their flights. Next is the buckshot in a cartridges has space which are filled with granular plastic material to cushion them. The plastic granular material prevents damage and provides uniform push to the projectiles. They ensure proper push to the projectile, which gives better spread and uniform velocities to the buckshot. The inventions have improved from aim, range, and ballistics of shotgun cartridges considerably. Next, we will learn about the cartridge cases. Like bullets, cartridge can be identified as have been fired from by a specific firearm. As soon as cartridges are loaded into a firearm, the potential for the transfer of unique tool marks exists. However, the cartridge does not have to be fired for these marks to be transferred. Simply loading a cartridge into a firearm can cause unique identifiable marks that can be later identified. Cartridge cases like those on the right are mostly made up of brass, but cannot also be made up of other materials such as steel and plastic. Cartridge cases came in variety of finishes, but all are made up of a material that is softer than the material found in a firearm. Any surface of a cartridge case that meets the inner working of a firearm may be marked. Tool marks produced on the cartridge cases will be in two basic forms, as the microscopic striations found on bullets. Cartridge cases can pick up striated action marks. These scratches are produced when the cartridge case moves laterally against the tool inner surface of the firearm, producing a scrap or striated mark. The other form of marks that can be left on a cartridge case are impressed action marks. Impressed marks are created on cartridge cases when it impacts the tool against the firearm with adequate velocity or pressure to leave an impressed or indented mark. Cartridge cases are compared to a fired standards from a firearm using a comparison microscope as described on the bullet identification. Standards are first examined to determine what marks, if any, the firearm is constantly reproducing. Evidence cartridge cases are then directly compared to the standards to see if they are too are also similarly marked. A cartridge case is also known as empty shell. It provides Housing for various components of cartridge. It is usually made up of brass for rifle, pistol, and revolver ammunition. For shotgun cartridge case is made from several layers of paper which are tightly compressed. The base of this paper shell is made up of brass. Plastic shells for shotgun are also being manufactured now. Those cartridge cases which are meant for high velocity weapons are long and bottlenecked. The base of cartridge case may be rimmed or rimless.
Summary. Ammunition means any artillery that can be used in combat or warfare like bomb, rifles, guns, machine guns, etc. Ammunition not only include the different types of arms used but also deals with different components in an ammunition like primer, propellant, cartridge cases, etc. There are different types of gunpowders, black powder being the primitive of all. Nowadays, smokeless powders are used in modern ammunition since they emit very less smoke and hence lesser burned propellant is left behind. Wads form an important part in a shotgun as it helps in perfecting the shots. Depending upon the type of shotgun, different types of wads are used like cushion wad, overshot wad, undershot wad, etc. Several types of compositions of cartridge cases are available according to the type of ammunition used. Thank you.